All right, Algebra 3, Lesson 30. Today we're going to be talking about addition of vectors. That's what they're calling here, find the resultant of. So we're going to talk about addition of vectors and overlapping triangles. Overlapping triangles is the proof that you see shown down below. So whenever they say write the answer in polar coordinates, what they're looking for is the hypotenuse of the terminal side and the um, the related angle that goes with it. You know what I'm saying? Okay. So you should have this up here. I'm going to go ahead and move this onto the next page so that you can see how this is actually going to work out. You follow me? Okay. So hopefully whenever I do that, what you see will be a little bit bigger. All right, so we want the resultant of where we're taking an angle that has a hypotenuse of 5 that has a related angle of 45 degrees. Careful now. And we're going to add to that an angle that has a hypotenuse at 7 with a related angle of 25 degrees. All right, so what we're looking at visually speaking here is something that looks like this, where this is 5. Okay, we're bringing this down. We're going to finish out that right triangle, right? And we see that this is 45 degrees. Okay? Then I'm going to come over here. We're looking at this, something similar to it. It's a little bit longer. Okay? This is 25 degrees. And this is 7. We want to know what happens whenever I add those two things together. Well, the first thing that I actually have to do is I need to find the x and the y for both of them, because I'm going to add the x's together, I'm going to add the y's together, and that's going to give me a whole new position that we're going to find an angle for based upon the new x and the new y, which I'll be able to get the hypotenuse from and the related angle from. Okay? So in terms of finding the x value of 5 at 45 degrees, okay, we would, once we do this once, we're going to see how to shortcut it. Okay? So what we're saying here, if I'm giving it to you right, is cosine 45 degrees equals x over 5. Does that make sense? Right, that's how I would find x. So yes, your graphing calculator will find parts of this. Okay? So what we're going to do is we're going to write 5 cosine 45, right? Now I have to make sure that I'm in degree mode whenever I start this. Okay? So from here on out, instead of writing cosine 45 equals x over 5, I can jump straight to 5 cosine 45 if I understand that I'm going to use my hypotenuse, cosine, angle, right? So that same thing works for finding y. Okay? So I don't need to write sine 45 equals y over 5. I can jump straight to 5 sine 45 if I understand that I'm going to use hypotenuse, what trig function represents x, degree, and then hypotenuse, which trig function represents y, degree. Do you see what I'm saying? Okay, so for my first x, right, we want to take this to, let's take it to 2 decimal places. So what's 5 cosine 45? Five cosine 45, you got 2.68? That's wrong. Double check your calculator. Are you in degree or radian mode? Try it again, Lexi. Was it in radians? So just so that we're aware, there's a reason that I say before we start, check your mode, right? Don't assume that it's in degree mode, because if you'll notice, the standard position on that graphing calculator is radian mode. So it will revert back to radian mode for whatever reason. I can't tell you why it does it, but it will. So you need to double check. There are times where it'll reset it. Okay, so I should, for 5 cosine 45, get 3.54. As Michael said, what do you get for 5 sine 45? And keep in mind, if it's a 45-degree angle, then it's a 45, 45, 90, which means that my other two sides, both legs should be the same, right? So I should get 3.54 on both of those, right? Because it's a 45, 45, 90. Now I need to do the same thing with the other triangle, but by now I should know that I'm going to get 7 cosine 25 and 7 sine 25. Okay, so I have 6.34. No, because notice that in this question was, does that mean that the y is going to be 6.34? No, because if you'll notice, the degree is not 45. It's 25, so it's not a 45, 45, 90 triangle, therefore the legs are not going to be the same length. All right, 7 sine 25, what did you say, David? 2.96, okay? And because we're adding these things together, I'm taking the results of my x's and I'm adding them together. Okay? And I'm going to take the results of my y's and I'm going to add them together. Okay? So 3.54 plus 6.34. What do you get? All right, so I got 9.88 for my x value. And what do I get for my y value? I should get 3.54 plus 2.96. Okay, just 6.5, right? Okay, so what that's telling me is that the resultant is going to go 9.88 to the right from the origin, and it's going to go up 6.5. Does this make sense? Now, later on, we'll talk about resultants that come from totally different quadrants and how that affects things, okay? So as we're looking at this, I should get something that looks like this, where this number is 9.88, okay, and this is 6.5. But because they're asking for polar coordinates, what's the first thing that shows up in your polar coordinate? My polar coordinate looks like this, right? What goes into that position first? The hypotenuse. Well, we should be aware that this is forming a right triangle, so how do I go about finding the hypotenuse? Okay, so 9.88 squared plus 6.5 squared equals c squared. What? Okay, then I would have to square root that, right? So I can do this all in my calculator in one shot. If I do the square root of 9.88 squared plus 6.5 squared, it will give me the answer in one deal. So because if it's an irrational decimal, right, if it gets to be a really long decimal, I'm going to get less of an exact answer by estimating and square rooting an estimate. So if I go ahead and do this off the beginning, right, square root 9.88 squared plus 6.5 squared, I should get a more exact answer to 2 decimal places, right? 11.83. All right, so we have 11.83 that goes here, okay? So we know from back up here that this is 11.83, correct? No, inverse tangent, okay, to get this right here. So that's giving me my degree, okay? So inverse tangent. Tangent is opposite over adjacent. So what's opposite of my reference angle? 6.5. Okay, and adjacent is 9.88. 33.34 degrees. 33.34 degrees. So this right here is my answer in polar coordinate form. Okay. Yeah, but the more in a statement is that that's as much work as trying to find 4 polar coordinates. If you understand, off the beginning, I drew a lot of stuff up here to make sense of it as we went. But when we go to do, say, the next one, we don't necessarily have to draw. We should understand it quicker, is what I'm saying. And the quicker that you understand it, right, the quicker the problem goes. Like I said, we're not going to have to think about this necessarily in terms of cosine 45 equals x over 5. If I know that these are going to be this way all the time, right, I'm writing 5 cosine 45. And in fact, let's do a test here and see if we can even do something with our graphic calculator a bit earlier on. If I can find it here. Let's see how much use we can make out of our graphing calculators, keeping in mind that we have to make sure that our mode, see, we checked here, we want to make that in degrees. Let's see how much this will do for me. All right. So if I write 5 cosine 45 and I add 7 cosine 25, I'm getting that 9.88 right there. So did I have to find a decimal and then add another decimal to it? No, I jumped right there, right? Now I can, I can do my 5 sine 45 plus 7 sine 25. Okay, so whenever I go to do this again, right, that even gives me a little bit more of an exact answer, doesn't it? Because it's not estimating at, it's not estimating at step 1 and step 2, right? It's giving an exact answer throughout, and then I can estimate that to be 6.49 instead of 6.5. I'll get more of an exact answer. Okay? So do we understand? And then, am I going to have to do the rest of it from here? Yes. Right? I'm still going to have to show the square root of, and then to get my hypotenuse, I'm still going to have to do the inverse tangent off of this. Right? But we can get quicker at it. All right, let's look at the next one. Let's see how good we can do here. Let's see, you guys, I can leave that last one up. What I would like to make sure that you guys can do is I want to make sure that you guys can do one of these on your own. Okay? So, let me make it a little bit bigger up here. It is, and it's still, you get a 45. Okay, this is an interesting one because it's a little different. So we might want to do this one together as well. So we have 7. We're still at 45 degrees, so that should be fairly easy. Plus 9. But what's tricky about this is that it's 148 degrees. Right? 148 degrees, is that going to be in the same quadrant? No. And once we come out of the first quadrant, we're going to have negative numbers, right? Okay? So let's look at this the way that it should be, right? We've got 7 here. So our x is positive and our y is positive. But it does help to draw these because this is out over here somewhere, right? Where, what do I know about my x value? It's going to be negative, but my y is going to be positive, right? So my calculator won't know that. It doesn't know what quadrant that we're putting this in. Okay? So what we're going to do off the beginning, though, so this one I can't plug in straight through on my calculator, but I am going to write 7 cosine what? 45. And then to get the y, I'm going to do what? 7 sine 45. Okay? We're going to get those two things to 2 decimal places. Plus, plus. And over here, I'm going to do what? What am I going to do to get my x value? No, not quite. What number came first over here? So now I get 9 cosine, but do I want to use 148? No, I want to use my reference angle, right? Okay, so what is my reference angle if from here to here is 148 degrees? What is this? And how do I find it? Subtract what from what? So I need 180 minus 148, 32 degrees. So I'm going to do 9 cosine what? No, it's not going to be negative 32. What I'm going to do, though, is because I know that it's negative, I'm going to put it there. Okay, does that make sense? Don't expect your calculator to give you the negative. So it's going to be negative, it's going to be negative 7.63. What did you get for 5 cosine 40 or 7 cosine 45? 4.95. Okay, so we should get 4.95 again there, right? And then down here, I'm getting 9 what? 9 sine 32, but this one, is it negative? No, because I know where I'm at, right? And I know my y is positive. 4.77. Okay? Now I want my x value, my new x value, and my new y value. What's 4.95 minus 7.63? No, I haven't. I haven't added them yet. I want you to add them. What, 4.95 plus negative 7.63, or just 4.95 minus 7.63? What? No. Negative 2.68. It's 4.95 minus 7.63, or plus negative 7.63. So what did you say that was? Negative 2.68. So I'm going to go to the left. So I see then that my resultant is going to be in the second quadrant then, right? Because what's 4.95 plus 4.77? Something like 9.72? Okay. So I know I'm up here then, negative 2.68, 9.72. Okay. So what I'm typing in here is not messing with the negatives because I'm looking at distance for the hypotenuse. I know it's hard to read. Okay, so I'm going to do, I mean, you can put them in if you want, but make sure you put them in parentheses. Negative 2.68 squared plus 9.77 squared. Okay, should give you the hypotenuse. Is it 7.2? Sorry. There we go. Fixed it. .08 is correct. Okay, so I got 10.08. Now we just need the degrees. The degrees are, we're going to use inverse tangent. Okay, 9.72 over 2.68. Remember, it doesn't know which quadrant you're in, so no. You don't put the negative in for the 2.68. What do you get? Do you get something like 74.59? Okay, now, before you put 74.59 into your polar coordinate, understand that what it's interested in knowing is it wants to know the degree from the initial side to the terminal side. So what do I need to do? Because what we're saying here is that this reference angle is 74.59. That doesn't mean that my resultant is 74.59. Because if I say 74.59, then what I begin to think then is what? If I wrote 10.08, 74.59 for my degrees, and that's all you knew, which quadrant would you put that in? I'd put it in the first quadrant. But I can tell from my picture here that my terminal side doesn't end in the first quadrant, does it? So I can't put 74.59. What do I have to do? I got to take, right, you're going to subtract 180 minus 74.59. 105.41 degrees. Do we understand why? So if your resultant is in the first quadrant, you're fine. Okay? But if I wind up in a different quadrant, I have to know the positive degrees from the initial side all the way around to that terminal side, whichever quadrant it's in. Does that make sense? Does everybody understand? Okay. All right, so we get 10.08, 105.41 degrees. All right. Let's see, number 3. Do you guys want to try this one out on your own? You need to try at least one on your own. So we're going to do 3, 36 degrees. That looks good. That's a first quadrant one. Plus 4 at 48 degrees. All right, so this is just like number 1 in the sense that I'm taking something that's in the first quadrant. I'm adding something that's in the first quadrant. So where should I wind up at? The first quadrant. So am I going to have to worry about subtracting something from 180? No, your answer is going to remain your answer. You don't have to do anything else there, so you don't have question 2, second step. Okay, so I'm going to hit pause on the video here, and as you guys work this out, then we'll come back, turn it back on. All right, and we're back. All right, so we've got some people with an answer. What did we get for a hypotenuse here? 6.96. Did everybody get 6.96? Katie, did you get 6.96? You never got there. Okay. All right. Did we get a degree? 42.9. 42 is correct. I got 7.9. Okay. So, Katie, did you get 3 cosine 36? Okay. What did you get there? 3 cosine 36. What'd you get? Did you write down any work for this? So you didn't work this out at all? Katie. All right, let me. Okay, so 3 cosine 36 should be 2.43, right? All right, what was 3 sine 36, Katie? 1.76. All right. Then we need what? What do I need to do next, Ashley?
I did the 4 cosine 48.
Okay, what's 4 cosine 48? 2.68. 4 sine 48? 2.97. Okay. Lexi, what did you do next? Added what? You mean the results, right? You added the results? Or did you do it all as one long stretch? All right, what did you get as a result for your x value? 5 point what? 5.11? Okay. I'm guessing that it took it further than that, did it not?
It took it from 0 something.
All right, I'm guessing it would probably round up to 5.11. All right, what did you get for your y value? 4.74. Okay, I had for some reason 4.73. Okay, so we can leave it as 5.10 then. And what did the y come out to exactly? Okay, so we lost a decimal, we picked up a decimal, probably is going to average out. Okay, so from there, right, we want the hypotenuse. So square root of 5.1 squared plus 4.74 squared, and we got 6.96. Okay, then we're going to do inverse tangent of what?
4.74.
Okay, and if it helps, what you could do up here is do sine on the top row, cosine on the bottom row. That way, because if I'm doing sine on top, cosine on the bottom, then it's not nearly as confusing whenever I get down here and I think about tangent as sine over cosine, right? So you should have gotten for your degree 42.79.
Okay, well, we got 42.9 with the ones that we got.
Okay.
But the way that they did it for 42.79 was they took like the 4.73 and 5.11.
Okay, so based upon the numbers that I had, it would come out to, so 42, it's not enough for it to be wrong, but 42.9, so 6.96, 42.9 degrees. My rule on a test with decimals is that it needs to be inside of 1,
So it has to be like
within 1.
0.0.
Needs to be within 1 either way. Okay, it could be 1 less, it could be 1 more within that decimal. So what I would have accepted, if let's say that I knew for sure it was 4.79, okay, I would take up to 43.79 or 41.79, right, within that decimal range. You understand what I'm saying? Okay. All right, we got to move on. There we go. All right, so you have a picture here. Shows you something like this. And I'm going to go ahead and show the overlap. Okay? Now, in the information that they tell you, and I need to go ahead and write in some letters here. Let's see, this goes around A, B, D. Oh gosh, this was what, E up here, wasn't it? E, C, so A, B, C, D, E, and what sound is that? Is that you, Emmanuel? All right. Unless that's involuntary, knock it off. All right. So the first thing, we got our statement, we got our reasons. All right. One of the things that I'm going to do, because they show you that what we're talking about here is overlapping triangles. So take AB out from its picture. Do you see what I'm saying? Take triangle ABC away from the picture. And then we're going to do the same thing with our other triangle. So we got D, C, B. Okay? That way I can look at these things independently and not being confused by the overlap. Okay? So we want to start off with our givens. So we know the angle ABC is congruent to angle DCB, given, right? So angle ABC is right here, okay? And angle, hold on, DCB is right there, right? So we see that. If we pull them apart, do we see that independently? If I leave it with just the picture, I'm going to be really confused because I've got lines that are cutting through here. What I'm seeing on the picture is I'm seeing this, right? Which gets confusing because I don't know which triangle I'm looking at, okay? They give me another given, though, and they say angle BCA is congruent to angle CBD. Okay, and that's given. But I'm going to look at where that's taking place at. Okay, BCA. So that's this guy right here to that guy right there. Okay? Right. Now, we want to see what they're trying to get us to prove. We want to prove that two segments are congruent. So I know right off the bat that first I'm going to have to prove that these two triangles are congruent. Then I can use CPCTC to prove that the corresponding parts are congruent. Does that make sense? All right. Now, looking at this picture up here, can I see anything else that's congruent in both of those triangles? Yeah, your third angles are congruent, and you could look at that if you want. But there's a quicker way. That would get me to angle, 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 but all that's going to tell me is that they're similar. I'm still going to have to prove a side, correct? Now, is there a side that I could find that might make my life easier? Michael? BA and CD, is that what you're saying? No, I don't have enough evidence to prove that. It doesn't. If they had told me that this was a regular pentagon, it would. Right? I've got one really easy blaring side congruence. Do I see a reflexive axiom anywhere? What is it? BC, right, Geneva? Right? Geneva saw it, and she's still working on corrections. Right? BC. BC is congruent to BC, right? Because they're the same line segment, right? So anytime I see in two triangles that have the same shared line segment, those things are going to be congruent. The same thing with angles. So I can say BC is congruent to BC reflexive axiom, right? Now, do I have enough information, or do I still need something else to prove that these triangles are congruent? Yes, we could go so far as to say that angle BAC is congruent to angle CDB, but do I need to? No. What do I have? I have angle side angle, so I can say triangle ABC is congruent to triangle DCB. Using what again? Angle side angle congruency postulate. All right, we could make those extra steps, but it's really just extra work and extra writing, which I don't want to do. Okay? All right, let's, so yeah, now we can say segment AC is congruent to segment D, what was it, DC? DB? DB? Okay? CPCTC. Okay? All right, and you can go through and you can look at a lot of different examples on this. Those pick up with page 207 in your book, Overlapping Triangles. You ought to look at examples. In fact, the one that we did is pretty, I mean, it's similar in form to what you see with example 30.4. You ought to look at as many examples as you can, because when you start seeing them show up in your homework, a lot of those similar types will be there. Okay? Questions about this? Again, my advice on overlapping triangles is to pull those triangles out of the picture so that you're seeing them independently, and then mark them as you go, right, with your tick marks for your angles, tick marks for your sides based upon whatever your givens are, whatever's obvious. Anything that's shared is reflexive. Be careful with, so be aware of that. So reflexive axiom and vertical angles. Knowing those two things are your best friends when writing proofs, okay? Because they're the easiest things to see and the easiest things to write down.